Okay, so the last part of that previous recording didn't quite get there, so I'll just recap that bit, which is our second answer here is 7 pi over 4. These are the two answers which are within our domain. This, so that's for theta, and then because theta is actually 2x, to get x we need to divide both of those answers by 2. So our final two answers for part A, 8 and 7 pi over 8. Alright, so now we're going to move on to part B. So we've still got, what we've got there of x was e to the power 2x sine of 2x, and f dashed of x was 2e to the power 2x sine of 2x cos of 2x. So now we need to do the double derivative. Again, we're going to use the product rule. So I'm going to say that u is 2e to the power 2x, v is sine of 2x plus cos of 2x. So u dashed is now, well, the derivative of just that bit would be x, so overall it's 4e to the power 2x, and v dashed, differentiate sine, we get cos, we also get 2 from the derivative of 2x. If we differentiate cos, we actually get minus sine, so then we get minus sine of 2x. So we've got our 4 parts, and the rule says that we multiply those 2 parts and then we multiply those 2 parts. So f double dashed of x is u dashed v plus uv dashed, with u and v and u dashed and v dashed there. So we've got these two multiplied, u dashed v, which is 4e to the power 2x sine 2x plus cos of 2x plus 2x 2 cos of 2x minus 2 sine of 2x. Okay, let's expand it and simplify, and a reminder, just take a quick look at the book, we are aiming to get the answer 8e to the power 2x cos x. We're aiming to get that answer, so hopefully these signs will all cancel out, and we've got a positive one there and a negative one there, so those two together we get 4e to the power 2x. Actually, I'll take that 2 there and that 2 there to get that as well. So this would be sine of 2x plus cos of 2x plus cos of 2x minus sine of 2x. So yes, the two sine bits cancel, and I'm left with 4e to the power 2x, 2 cos of 2x, which is 8e to the power 2x, x, as required. So finally we're going to do part C, which is asking which, determining which basically are the maximum or minimum of these 2 points. So the 2 turning points that we found, 3 pi over 8 and 7 pi over 8, are they a maximum or are they a minimum? A local maximum or a local minimum. So the way we do that is we substitute them into our double derivative, and if the double derivative is negative, it's a local maximum, and if the double derivative is positive, it's a local minimum. Okay, why is that? Well, the double derivative, the first derivative tells you the gradient, how the function is changing. This tells you like kind of how the gradient is changing. So if you think about the shape of a maximum, it looks like this. How is that gradient changing? Well, the gradient starts positive, and then it kind of gets flatter until it reaches 0, and then it's negative, and it gets more negative. So how is this changing? It's going down. It's going from positive to negative. So if the double derivative is negative, that indicates we've got a maximum. And similarly with the minimum, this is the kind of shape of a minimum. It starts negative, and it gets less negative until it reaches 0, then it's positive. So it's going up. So the rate of change of the gradient there is positive. That's why that works. So for x equals 3 pi over 8, actually, good notation to use is this. F double dashed of 3 pi over 8 is, in some ways we don't really even need to bother with this part, because this bit is always positive. Okay? It's only whether the cos part is positive. So I'll write it in anyway. We've got e to the power 2 something. I'm not going to bother with that because I know it's positive. Cos of 3 pi over 4. And then the f double dashed of 7 pi over 8 is the same, 8 e to something positive, cos of 7 pi over 4. So I need to now figure out whether this and this are positive and negative. So I'll draw out my cos curve. My cos curve, remember, looks like this, roughly like that. This is pi over 2. This is pi, where it reaches a minimum of -1. Here at 0 again at 3 pi over 2, and then at 2 pi it is 1 again. So cos of 3/4 pi is here, right? So that's negative. So this whole thing is negative, which means 3 pi over 8, or when x is 3 pi over 8, that's a maximum. Second derivative negative, it's a maximum. And 7/4 of pi, that's just 1/4 under here, that's here. So that is positive. This is positive, that's positive, the whole thing's positive, which means that the second derivative is positive, so 7 pi over 8 is a minimum. So that is called classifying the points. So we classify those. Local maximum and local minimum. And we're done.